In this video, we're going to be discussing trig ratios and how these sides of a right triangle relate to each other. Alright, so we're going to start off with this first triangle where P is going to be our right angle. The vertical leg is going to be 3 units long. The horizontal leg is going to be 4. Alright, for this chart down here, we're going to be talking about angle Q and how the sides relate to it. The leg that is away from it, we're going to call the opposite leg. So this leg that is 3 units long is going to be the opposite leg of angle Q because it is away from it. The adjacent leg will be the one that is next to it. And then the hypotenuse will be along the side of the triangle. Alright, so as you can see, the opposite leg is 3, the adjacent leg is 4, and by either Pythagorean theorem or Pythagorean triples, we can discover that the hypotenuse is going to be 5 units long. If I take this second triangle, which is just a dilation of the original one by a scale factor of 2, so all the sides are twice as long, the opposite leg is now 6 units long. The adjacent leg, the one next to angle Q, is now 8 units long, and the hypotenuse is 10 units long. And lastly, if I take this green triangle, the third one, which is a dilation of the original triangle by a scale factor of 3, by multiplying all the side lengths of triangle 1 by 3, we get 9, 12, and 15. Alright, let's fill out the chart here on the bottom now. Alright, the sine of angle Q means you put the opposite length over the hypotenuse. So for triangle 1, the opposite length over the hypotenuse is going to be 3 over 5. Cosine of angle Q is going to be the adjacent length over our hypotenuse. So it's going to be 4 over 5. And the tangent of angle Q will be the opposite leg length over the adjacent length. So 3 over 4. Let's go to triangle 2. For sine of angle Q, we're going to do opposite over our hypotenuse, which is going to be 6 over 8. Oh, I'm sorry, 6 over 10, opposite over our hypotenuse. 6 over 10 reduces to 3/5. Cosine of angle Q is the adjacent length, 8, over the hypotenuse, 10, 8 over 10. 8 over 10 reduces to 4/5. Tangent of angle Q is the opposite of adjacent, so it's going to be 9 over 12, which reduces to 3/4. Notice that both row 1 and row 2 are identical. So go to triangle 3 and you can assume what's going to happen there. The sine of angle Q would be the opposite of our hypotenuse, so 9 over 15. 9 over 15 reduces to 3/5. Same fraction as the first two. Their cosine of angle Q would be adjacent over hypotenuse, 12 over 15, which reduces to 4/5. And tangent of angle Q is going to be opposite over adjacent, which will be 9 over 12, which simplifies to 3/4. So notice that no matter what triangle we dealt with, the sine of angle Q was always the same ratio, 3 to 5. The cosine of angle Q was always the same ratio, 4 to 5. And the tangent of angle Q was always the same ratio, 3 to 4. That's because all these triangles are similar. So in summary, the sine of an angle is its opposite leg divided by the hypotenuse. The cosine of an angle is the adjacent leg over the hypotenuse. And the tangent of an angle is the opposite leg over the adjacent leg. A mnemonic that will help you out is the word SOHCAHTOA. SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. and tangent is opposite over adjacent. SOHCAHTOA. On a 45-45-90 triangle, it's isosceles. So let's say these sides are 1, 1, and the square root of 2. Alright, so let's deal with this angle down here. The opposite leg would be this leg. The adjacent leg would be this bottom leg. And the hypotenuse would be this side. So the sine of 45 degrees is going to be the opposite over the hypotenuse. 1 divided by square root of 2, which when you simplify, put it in simplified radical form, is the square root of 2 over 2. Notice cosine of 45 degrees is going to be the same value because the adjacent leg is also 1 and the hypotenuse is square root of 2. So it too is the same value. So when you simplify it, you get the same fraction, same ratio. The tangent of 45 degrees, that's the TOA part of SOHCAHTOA, is opposite over adjacent. So it's this 1 over 1. So the tangent of 45 degrees is 1. Now let's look at a 30-60-90 triangle. With this relationship here. The side opposite 30, the shorter leg is going to be 1, so that means the side opposite 60 is going to be that times the square root of 3, so 1 times square root of 3. And remember that the hypotenuse is always double the shorter leg. So let's do the sine of 30 degrees. In this case, let's label. Here's the opposite leg. Here's the adjacent leg. And there's the hypotenuse. So sine of 30 degrees. SOHCAHTOA. So it's opposite over hypotenuse. 1/2. Cosine of 30 degrees is adjacent over hypotenuse. So it is square root of 3 over 2. And the tangent of 30 degrees, SOHCAHTOA, so it's opposite over adjacent. It is 1 over square root of 3, which you simplify by multiplying by the square root of 3 in the numerator and denominator, and you get square root of 3 over 3. There's the 3 trig ratios for 30-degree angle. What if we want to refer to the 60-degree angle? Well, what happens now is the opposite leg is no longer 1. The opposite leg is the square root of 3. The adjacent leg is the side that is 1. It's a shorter leg. And 2 is still the hypotenuse. So the sine of 60 degrees is opposite over hypotenuse. So it's square root of 3 over 2. Cosine of 60 degrees is the adjacent over the hypotenuse, so it is 1 over 2. And the tangent of 60 degrees is opposite over adjacent, so square root of 3 over 1, which is just the square root of 3. So in summary, SOHCAHTOA will help you remember what all 3 trig functions are: sine, cosine, and tangent.